Chapter 4, Section A, Review. Learning target. I will be able to show mastery of the concept learned in Chapter 4A. So what have we discussed in Chapter 4A? This is the first part in geometry that we talk about the 6 trig ratios. We start with the lesson converting from the degree to radians, finding the quadrant where the angle lies, and then we move on to finding the 6 trig ratios. So these are the basic concepts that we will be covering in the first 4A sections. Now let's take a look at the examples. Number 1, 7 pi over 4. Which quadrant will you find this angle? 7 pi over 4 equals, so I like to use the degree to tell me where it lies. I'm not so comfortable with the radians. So the easiest way for me to do this problem would be 7 times pi. So pi, I ask you guys to replace it as 180. 7 times 180 divided by 4, I have 315 degrees. 315 degrees is greater than 270 degrees and less than 360 degrees. So I know the angle is going to lie in the 4th quadrant. So that's how I get the 4th quadrant, 315 degrees. And we calculate the degree is going to be 315. What's the reference angle? So the reference angle is like taking with respect to the x-axis. So the closest one would be 360. 360 minus 315. I have 45 degrees. How about coterminal? Positive coterminals. So coterminal means that they are using the same initial side and end up with the same terminal side. So the easiest way for me to find a positive coterminal angle would be by adding 2 pi. I'm given the radians, so I'm going to add 2 pi. 7 pi plus 4. 7 pi over 4 plus 2 pi. So rewriting 2 pi into improper form, which is 8 pi over 4. 7 plus 8, I have 15 pi over 4. Negative coterminal angles. So the easiest way would be I subtract 360s. So 7 pi minus 2 pi, I have negative pi over 4. So that means I'm measuring the angle in the clockwise directions, which they share the same initial side and terminal side, negative pi over 4. Example number 2, 300 degrees. Where will you find the 300 degree angles? So 300 degree is greater than 270s and less than 360s. So again, it's going to lie in the 4th quadrant. The radians, so if you forget how to convert from degree to radian, make sure you practice this. So as I said, you can take the given angle, which is 300 degree, divided by 360s, multiply that by 2 pi. 300 divided by 360s, multiply by 2 pi, reduce, simplify as you can. So we can reduce the whole thing down to 5 pi over 3. What's the reference angle? So again, the closest one would be 360. Take 360 minus 300, the given angle. That's 60 degrees, and that's going to be our reference angles. Positive coterminal angles. So I take 300 plus 360 to go around one circle, which is 660s. Negative coterminal angles, 300 minus 360, I have negative 60 degrees. Number 3, 5 pi over 6. 5 pi over 6 is going to fall in the 2nd quadrant. The degree measurement is going to be, again, replace the pi with 180. So that's 5 times 180 divided by 6. 180 divided by 6, that's 30. 5 times 30, that's 150 degrees. So that's why it's going to lie in the 2nd quadrant. What's the reference angle? Now the closest angle to the x-axis would be 180 degrees. 180 minus 150 degrees. The reference angle is going to be 30 degrees. Positive coterminal angle. So I take 5 pi over 6 plus 2 pi. That's 17 pi over 6. Negative coterminal angle, 5 pi over 6 minus 2 pi. That's equal to negative 7 pi over 6. Number 4, 240 degrees. It's going to be 240 is greater than 180 but less than 270. So it's going to lie in the third quadrant. The radian is going to be represented as 240 divided by 360, then multiply by 2 pi. So that's 4 pi over 3. The reference angle, 240 minus 180, so that's 60 degrees. Positive coterminal angle, 240 plus 360, I have 600 degrees. Negative coterminal angles, 240 minus 360, that's negative 120 degrees. The point listed is on the terminal side of an angle in standard position. So remember we defined what's the terminal side at the beginning of the lesson. The initial side, you need two sides to form the angles. So initial side is always set to the positive x-axis. And where the terminal side ends is the other side. So this is asking you to sketch the angle and find the exact value of the 6 trig ratio functions of the angle. Number 5, 8, 15. So x value is 8, y is 15. Remember I said x is always going to be the adjacent side. Opposite is always going to be your y value. So first we need to calculate the hypotenuse. Hypotenuse applying the Pythagorean theorem. 8 squared plus 15 squared equals the hypotenuse squared. So your hypotenuse is going to be square root of 8 squared plus 15 squared, which is 289. Square root of 289 equals 17. So the hypotenuse is going to be 17. Plug in the numbers for the definition of the 6 trig ratios. So sine equals opposite over hypotenuse. Opposite is always your y value, so 15 over 17. Cosine is adjacent over hypotenuse. Adjacent is always the x value, so that's 8 over 17. Tangent is opposite over adjacent, so it's always going to be y over x, 15 over 8. Once you have these 3 values for the trig functions, then the next 3 is taking the reciprocals. So cosecant is the reciprocal of sine, so all I have to do is just swap these 2 numbers. So cosecant is going to be 17 over 5. Secant is the reciprocal of cosine, so it's going to be 17 over 8. Cotangent is the reciprocal of cotangent, so it's going to be 8 over 15. And that's how I find the 6 trig ratio values. Number 6, negative 4, negative 3. So negative 4, so goes the x in negative 4. Y has a value of negative 3. So we can find this point, this angle is going to fly in the third quadrant. So 3, 4, the Pythagorean theorem should tell us 5 as the hypotenuse. That's the Pythagorean triples. So what's going to be the sine, the 6 trig ratios? So sine theta is going to be, so opposite is negative 3. Again, opposite is always your y value. Negative 3 over 5. Cosine, adjacent over hypotenuse. X is always your adjacent. Negative 4 over 5. Tangent, opposite over adjacent. Negative 4, negative 3 over negative 4, which is 3 over 4. Cosecant is the reciprocal of sine, which is negative 5 over 3. Secant is the reciprocal of cosine, which is negative 5 over 4. Tangent is the reciprocal of cotangent is the reciprocal of tangent, which is 4 over 3. Number 7, using the same concept. 5, negative 12. You'll find this terminal side is going to lie in the fourth quadrant. 5, negative 12. So that's in the fourth quadrant. How about the hypotenuse? Hypotenuse is going to be the square root of 5 square plus 12 square, which is 169. Square root of 169 is 13. So that's our hypotenuse. Plug it in for the 6-trig ratio values. So sine, I have negative 12 over 13. Cosine, 5 over 13. Tangent, negative 12 over 5. The rest of the 3, again, take the reciprocals. So cosecant is going to be negative 13 over 12. Secant is 13 over 5. Cotangent equals negative 5 over 12. State the quadrant in which theta lies. So this part you will have to think. In each quadrant, what are the trig ratios that's positive and what are the negative ones? Number 8, sine theta less than 0. So when will your sine be less than 0, a negative sign? You will find it at third and fourth quadrant. Cosine theta less than 0. When will your cosine theta be less than 0? That's going to be in the second and the third quadrant. So which quadrant has both, would satisfy both functions? So it looks like number 3, the third quadrant. That's why I circle both of them, third quadrant. So the final answer for number 8 is going to be third quadrant. Number 9, cotangent theta greater than 0. When will your cotangent theta greater than 0? So whenever it comes to cotangent, I think about tangent. Tangent and cotangent are reciprocal of each other, so they should have the same sign. So when will your tangent be greater than 0? Tangent is going to be positive at first and the third quadrant. Cosine theta less than 0. When will your cosine be less than 0? Cosine is less than 0 in the second and the third quadrant because it's adjacent over hypotenuse. Adjacent is negative in the second and the third quadrant. So which quadrant satisfy both of them? Now you see I circle third quadrant for both. So it's going to be in the third quadrant. Number 10, secant theta greater than 0. Secant, I think about cosine. When will your cosine be positive? Cosine is positive in the first and the fourth quadrant. How about cosecant theta less than 0? So please put on a theta. There's a typo there. Cosecant theta less than 0. So that means I'm looking at the sine theta. When will your sine theta be less than 0, a negative number? Sine theta is negative when it's in the third or the fourth quadrant. So which quadrant satisfy both? It's going to be the fourth quadrant. Number 11, find the values of sine, cosine, and tangent given the followings. So again, you will have to find where the angle lies first. Cosine theta equals 3 over 5. Cosine theta is positive in first and fourth quadrant. And cotangent theta less than 0. Cotangent theta, I think about tangent. When will your tangent be negative value? Tangent is negative in the second and the fourth quadrant. So only fourth quadrant satisfy both of them. So my angle is going to lie in the fourth quadrant. Don't forget that part. Cosine theta is defined as adjacent over hypotenuse. Adjacent over hypotenuse. So I'm going to set my adjacent side as 3, hypotenuse as 5. Adjacent side as 3, hypotenuse as 5. So I can calculate the opposite side. So how do I calculate the opposite side? I'm using the Pythagorean theorem. The square root of hypotenuse squared minus the adjacent side squared, which is 25 minus 9. So that's square root of 16 equals, square root of 16 equals 4. So I know my opposite side is going to be 4. So what's going to be the value for sine, cosine, and tangent? So sine is defined as opposite over hypotenuse, which is negative 4 over 5 because we are in the fourth quadrant. Cosine is defined as adjacent over hypotenuse, and we are given this information in the question. Cosine theta So I can basically just copy it down here, 5 over 3, 3 over 5. That's like a given points away. Tangent theta, tangent is opposite over hypotenuse. I'm sorry, tangent is opposite over adjacent. Opposite over adjacent. So we should have negative 4 over 3. Negative 4 over 3 because it's in the fourth quadrant. So your tangent should be a negative value. So don't forget, negative 4 over 3. Number 12. Tangent theta equals a negative number. So that means tangent is less than 0. Where will you find the angle that has a tangent less than 0? It's going to be in the second or the fourth quadrant. And in the next condition, your theta would be in between 0 and pi. So that means from first and the second quadrant, only in the first and the second quadrant. So which one satisfies both of them? So obviously, you can only have angles in the second quadrant. So tangent equals opposite over adjacent. Opposite over adjacent. Opposite over adjacent, and we were given the information of negative 5 over 12. But in second quadrant, opposite is always positive. So I'm going to put it as 5 over negative 12. So it doesn't really matter if I put the negative on the numerator or the denominators. So they can be the same. They are the same values. So opposite is positive in second quadrant. Adjacent is negative in second quadrant. So with this, I can calculate the hypotenuse. So again, this is the Pythagorean triples, 5, 12, 13. And that's the main reason why I ask you guys to practice the Pythagorean triples. Pythagorean triples, if you are very familiar with it, you don't even have to calculate. You simply get the hypotenuse from the Pythagorean triples. So that's 13. So our sine is going to be, in second quadrant, sine is positive, 5 over 13. In second quadrant, cosine is going to be negative, negative 12 over 13. In second quadrant, tangent is negative, negative 5 over 12. And especially, we were given the tangent in the question. So again, this is like a given away point, negative 5 over 12. The last one, fill in the chart with the exact values. So again, I'm not asking you to put these values on your calculators and then give me decimal numbers. It has to be exact. So meaning that the ratio would have to be kept in the rational format with the square root or decimal form or the fraction numbers. Okay, so don't ever give me the numbers on your calculator by just punching in these numbers. I need the exact values, and you cannot get this from your calculators. So basically, you either practice it, use your special right triangles, 30, 60, 90 degrees, and the 45, 45, 90 degrees right triangles, or you just have to memorize them. So go ahead and check your answers. Practice and practice and practice.